Yeah, good evening, everyone. So, in our last videos, we have seen very clearly about how this graph data structure is going to work and some of the algorithms based on graph data structures we covered very clearly in our last videos, sir. Now, in today's session, I want to talk about a special concept which is nothing but priority queues. I don't want to go in detail into this. So let me talk what is meant by priority queues. Sir, actually, if you take any example, for example, first I will take example. Sir, assume MSET ranking or anywhere student ranking management. Okay, sir, student ranking system. If you take a student ranking system, it is implemented based on priority queues only, sir. Okay, for example, in a college or in a group, suppose if four students are there, sir, first student rank is a 10, second student rank is nothing but otherwise, sir, 10 marks he got. Okay, sir, he got 70 marks. Next, then he got 80 marks. Then he got 30 marks. Sir, how we are allocating the ranks? This person will get first rank. First processing should be for this person. So seat allotment, something like that. Sir, this one is nothing but second rank, second priority. And this one is nothing but third priority. This one is nothing but fourth priority. Sir, how we are giving priority? So based on the highest marks, something like marks in descending order. In this strategy, we are allocating the ranks, right? So student ranking system is implemented based on priority queue only. Sir, some universities consider they are implementing this ranking system, sir, based on percentages. Means then what will happen? Again, based on percentages, we will implement that priority queue. It may change, we can't give guarantee. Sir, sometimes, for example, based on a person age, we need to give highest priority. For example, if you take at the time of COVID situations, okay, so the highest priority is given to old age people. Okay, so in such cases, priority is given for old age people. Okay, similarly, if you take, sir, hospitals, in the hospitals also you can see the allocation of beds is based on some algorithm, right? Based on the severity of the disease. For example, if a person is suffering from cold, or if a person is suffering from fever, if a person is suffering from headache, sir, then one accident person came. So to whom they are going to allocate bed first? The person who met with an accident. Have you observed, sir, how this processing is happening? It is depending on the severity of the problem. Sir, same case here also we can able to get, sir. Sir, in all these cases, we are implementing which one, sir? Priority queue. Okay, in all these cases, we are implementing priority queues. Sir, already priority queues is there in Java. So Java collections is there, right? In that there is, so one separate class is designed for priority queue, sir. Okay, sir, this priority queue contains three main methods. One is to add the objects. Second one is to remove the object. Third one is peak. If you see, actually, after completion of this, if I take a graphs, then it will be good. But unfortunately, first I have taken graph, because in the majority of the applications, if you observe in our graph, suppose if I have, sir, two edges in this style. Sir, in this case, we are going to select the minimum edge cost. For example, if these two are there, it is going to select this one directly. Sir, how it is happening? Because we inserted this in the queue, we inserted this in the queue. Which one it is going to select? Shortest. So based on the priorities, it is going to work. Okay, that one we have seen already, but technically I'm going to provide here. So in the Java collections, already we have priority queue classes there which support these methods, sir. Now, I want to implement one small applications based on these priority queues, how it is going to work. right? For example, consider I have test class is there here. I have test class is there here. So in this test class, I want to create one priority queue, sir. Priority queue, which is going to hold integer objects. PQ is equal to, so new priority queue of empty. Like this I'm taking. Sir, PQ dot add of, I'm going to add 3 first. PQ dot add of, I'm adding 1 next. PQ dot add of, I'm adding 5. So next PQ dot add of 4. Like this, I added some objects. I added some objects. Now my requirement is don't display that priority queue, because internally it maintains some heap structure. It is going to maintain some heap structure. Okay, so later I will show you how the heap structure is. So until this priority queue is empty, is not empty, okay, not of priority queue, that means if our priority queue is not empty, can you please display the topmost element what we have, pq dot pick. Then immediately you have to remove, sir. Then only priority queue is going to work properly. Okay, because it is assigned based on priority. Suppose in my priority queue, so if I am giving, so ranks according to the student roll number, something like that. For example, so 70, roll number 70 is having highest marks. Next roll number 12 is having next level marks. Next low roll number 60 is having next level mark. Next roll number 90 is having next level mark. Sir, first we have to process this 70. So you have to delete after processing. Then only you can able to process this 12, sir. Okay, it is based on internally like this. That's why, sir, it is not possible. It is not possible to display all the elements at a time. Compulsory, you have to process one by one. So internally, how it will be? Sir, first I will execute the code, then you people will get some idea. Then I will show you how it is going to work. Really, is it a priority queue technique is following or not? First, we have to check. Have you observed? It is coming in the order, but in our insertion, we have not given in the order, sir. Sir, how it is going to be added? Listen carefully. 1 second. Right. How it is going to be added? Have a look once. Sir, first we added 3. Actually, 1 will be there here. Okay. So 1 will be there here. So next term, no. For example, if I am adding 3 here, so the next object will be always. Okay. So the next object is always. For example, if you take 1 only, no problem. 1. So here I am going to take which element I can take. Okay, I am taking 3. Otherwise, I will take 2. And here I am going to take 4. And here we have to take 3. And here we have to take 5. Sir, what is this style? Is it a tree? Yes. Sir, is it a binary tree? Yes. Is it a binary search tree? No. Sir, I will explain later about this special tree. Don't worry at all. Now observe carefully. Sir, here the simple formula, the node which is there at the top is nothing but having highest priority. That's why in the output we got first 1. After this, after deletion of 1, what we have to do? We have to heapify this tree. We have to heapify this tree. Then only, sir, you are going to get next processing value. Next processing value, like this it will be there, sir. Okay, like this it will be there. Like this. Sir, next you have to pick this element. That means 2. Then remove these 2. Then only you will get a chance for the next one. Like this. So next we have to delete this. So next only we are going to get a chance for 4. Then we have to delete this. Then only 5 will be getting a chance. Like this it is going to work, sir. This is for ascending. This is for ascending. But how it is going to work for descending in the sense? A small modification in this program which will print the content in descending order, sir. So I will show you how it is going to work in descending order also. Sir, very simple. In collection framework, already we have one special constructor is there. So collections dot reverse order. If you take like this, automatically it is going to display the values in descending order. Okay. This is nothing but how internally our priority queue is implemented. Sir, how it is going to select one, how it is going to select two, I want to know. Don't worry, I will explain the process so that you people will get full-fledged clarity. Can you please confirm, is the outline of this particular concept, is it clear for you people, sir? Is the outline is clear for everyone? Please confirm. Right. So next, sir, is it applicable only for integer objects, string objects like this? Can't we apply for student objects? Yes, you can do this for student objects also. I am taking student class, and then I am going to take integer. Otherwise, for student, we will take a string name of the student. Okay. So followed by integer age of the student. Like this, I am going to take, sir. So now I will write a constructor which is going to receive a name and followed by age of the student. So current student name will become name. So current student age will become age. Now I want to insert student type of objects here. Student type of objects here. Sir, can I take a student type of objects? Yes, no problem. No issue at all. Sir, how to create? I am taking new student of so triple A with age as 34. Here I am creating so new student of triple B with age 20. So here I am creating new student, sir, with age triple C, with age so triple C, and with name triple C, age is nothing but a 10. And here I am taking so new student with name triple D and age is nothing but 30, something like this. And here I am creating one more student so with the name triple E, and then age is nothing but 25. Now, sir, based on what activity you are storing the data, compulsory you have to mention. So you can't run this program directly, sir. If you are running, it is going to show one error message. What is that error message? So at the time of execution, you can able to see, sir, class cast exception. Class student cannot be converted to comparable. Okay, because if you want to store the data in priority queue based on some condition, I have to sort. Sir, where is that condition? You have not mentioned. That's why compulsory this student class must implements, this student class must implements one special interface is there with name comparable, which is going to take student object. So if you are writing these, we have to implement one special method called compare to. So how you are going to compare two student objects? Sir, just I am going to return current object age minus student dot age. Based on the ages, I am going to compare. Suppose if I have first student with age 30, second student with age 20. So 30 minus 20, it is going to return positive value. Yes, it is there in ascending order. Suppose if you want a descending order, then you can interchange these two, sir. Like that we are going to get. Here if it is 20 and then 30, so 20 minus 30, we are going to get negative value. In this case, S1 is greater than S2. In this case, S1 is less than S2. And if first age is 20, second age is 20, then 20 minus 20, we are going to get 0. So S1 is equal to S2. Sir, how these comparisons is going to be happen, that internally it will take care. So that's what logic we have written compare. Now, is it going to entertain? Yes, no problem. The code will compile fine and even you can execute. Sir, we are getting this student object information. So if I want to get the object content, we have to override one more method. What is that method? ToString. Okay, I will return a string so with some parenthesis where so this dot name I will take so followed by plus comma. Okay, so plus this dot age I will take so followed by plus something like this. Yes, sir. Now let us see, sir, which object we are getting first, because triple C, because his name, his age is nothing but very small when compared with remaining. So like this we are going to get the content, sir. This is the purpose of priority queue. Now Sir, can I take these values in descending order? Yes, we know already. I have given the clear clarity how we are going to get in the descending order. If you want to get in the descending order, what we have to do while constructing the priority queue, just we have to take so collection dot. Okay, so collections dot reverse order. If you take, automatically it is going to do in the reverse order comparison, sir. Okay, now you can see 34 student got first priority. This is the way internally how our priority queue is going to work. Can't we implement this priority queue by ourselves? Yes, we can do that process with the example I will show you. Can you please confirm, is the concept is clear for you people? I request everyone to please respond. Yes, I request everyone to please respond. Clear up to this? Right. So next one, sir, what is this heap? What is this heap? Very simple, sir. Three properties, three rules are there. First rule is nothing but it is a binary tree. It is a binary tree. Binary tree means what? Sir, it should contain, okay, at least, or sorry, not at least, at most two children. At most two children. Sir, at most two children means what? It can have so one or zero or more children. Okay. Sir, can I say, is it a heap? Is it a heap? Yes, it is the heap. Okay. Sir, like that, it should be a binary tree and it should contain at most two children. At most two means what? Either 0 or 1 or 2. Right. Sir, next one, second rule for this heap is nothing but, sir, it should be, it should be a complete binary tree, sir. It should be a complete binary tree. CBST, complete binary tree. Sorry, CBT, complete binary tree. Sir, when we can say this tree is complete binary tree, when we can able to say, sir, complete binary tree, CBT, is a tree, okay, so in which all the levels are completely so filled, except possibly possibly last node, except last one, remaining all the nodes are completely filled, sir. Okay, and so which is filled from top to bottom and left to right, like this we should have, sir. Sir, I will give some examples so that you can understand very clearly. Sir, let me take one simple diagram here. So I'm going to take some nodes, like I have a root node here. Then we have a children, we have a children, we have a children, we have a children. Sir, is it a complete binary tree? Is it a complete binary tree means? Yes. Why? Sir, here at level 1 we have the node, at level 2 nodes are there, at level 3 nodes are there, but these nodes is not there. But no problem, it is following left to right. Next, sir, can I say, is it a complete binary tree? No, sir, it is not a complete binary tree because level 1, okay, level 2 is also okay, but level 3, actually, this node should come here, right? This node should come here because level wise we are filling. That's why, sir, it is not a binary tree, sir. Okay, so binary, what you can call complete binary tree. Sir, now I have a nodes like this. Sir, is it a complete binary tree means? Yes. First level complete, second level complete, third level, one empty field is there, but it is starting from left to right, no problem. So if you are interested in next node, it should be inserted here. Now, sir, can I take, is it a complete binary tree? No, sir, it is not complete because first level, okay, second level, okay, third level, actually this node should be present here. This node can be empty. Okay, it is not in left to right manner. That's why it is not a complete binary tree. Okay, sir, next and after that. So can I take is it a complete binary tree? Yes, all the levels are filled perfectly, right? So that's why it is a complete binary tree. Sir, can I take, is it a complete binary tree? First level, okay. But in the second level, you should not take node here. It should be here. Okay, this node should be here and this node should be here. Okay, means like this it should be there, but it is not a complete binary. Okay, sir, in this case, first one is a complete binary tree, but not this one. This one is complete binary tree, not this one. This one is complete binary tree, but not this one. I think the property of complete binary tree, it is very clear for you people. I think so. Can you please confirm, friends? Is it clear up to this? Please confirm. Right. So next one. Next one. Sir, what is the next third rule? Only three rules. What is the third rule here is nothing but, sir, heap order priority. Heap order priority should be there. Sir, how you can able to decide? Very simple. The children, whatever you are taking, it should be always greater than or equal to, sir, parent node. Parent node. This is called as max heap. Okay, children should be always greater than parent node. And in other case, sir, children should be less than or equal to, so children should be less than or equal to, sir, parent node. Your children should be less than or equal to parent node. Sir, if it is the case, okay, if it is the case, so then it is called as actually this one is max heap, sir. Okay, this one is called as max heap and this one is called as min heap. Don't worry, I will take some examples for you to understand. Listen, very simple. Suppose if I am taking a node 10 here. Okay, a node 10 is there. Sir, for this 4, next and after that 5. So next and after that 1, next and after that 2. Yes, it is a complete binary tree. Okay, I mean it is following this heap order priority queue. Sir, have you observed? The root node is always greater than this 5, greater than this 4, and this one greater than 1, greater than 2. Yes. Now if I am taking 1, left subtree is 2, right subtree is nothing but 4. For this left subtree is nothing but 5, right subtree is nothing but 10. Yes, here minimum is there. It should be less than 4, it should be less than 2. Sir, it should be less than 10, it should be less than 5. Yes. So this one is called as what, sir? Min heap, min heap. And this one is called as what, sir? Max heap. Like this we have. Okay. Can you please confirm, is the concept of heap, how it will be? These three rules are clear for you people? Please confirm, everyone. Right. Now, see, we can't implement. Okay, so we can't implement. So heap data structure. We can't implement heap data structure by using classes concept, sir. Sir, why we are unable to implement this by using classes concept? The simple reason is nothing but the positions are not fixed. The positions are not fixed. It is keep on changing. We can't traverse each and every time and we can't predict. But if you take either array or array list, sir, we can give guarantee for the position, right? We can give positional activities. We can do positional activities. So for that, we are using this array or array list to represent this heap structure, sir. Okay. Anyway, don't worry. I will take example so that you people will get clarity. Sir, I want to insert the data in heap. I want to insert the data in heap. So how you can able to insert the data in heap? Listen carefully. For example, consider I have some nodes are there, like 2 is nothing but one node. Then so 3 is nothing but another data what we have. Sir, 4 is nothing but another data what we have. So 5 is nothing but another data what we have, and 10 is nothing but another data. Now in this I want to insert one, sir. I want to insert one. Sir, how to insert this one? Very simple. You know the position, right? You know the position. So perfectly where it can be inserted, we know very well. Sir, this one is which heap? Min heap, because minimum element should be available at the top. Sir, where we are going to insert that one? One. Sir, actual position is nothing but this one, right? But already it is in array format. Okay. So in the array, if I want to store this value, let it be in already 0th position. Okay. 0th position and first position, second position. So third position, and we have fourth position. Like this we have considered just for our understanding. Sir, this is 0th position, first position, second position. So third position, fourth position. You know very well about this representation. Sir, here we have 2 is there. Here we have 3 is there. Here we have 4 is there. Here we have 5 is there. Here we have 10 is there. Sir, easy to identify the levels. That's why we are using this representation. Okay. Easy to identify the levels. Suppose consider I want to insert one value. Where it is going to be inserted? It will insert at the ending. Sir, is my heap property is going to satisfy here? No. Once if you add to the last, sir, is it going to satisfy our heap properties? No, it is not satisfying. Sir, if it is not satisfying the heap property, sir, what we have to do? Okay, if it is not satisfying the heap property, what we have to do? Sir, we need to write some code to perform some activities. What are those activities? That is called as, sir, do you know heapify? Heapify, that is called as heapify. Sir, I will explain that process first of all, then we will write code for understanding clearly, sir. Sir, how you can able to do this heapify? First, try to identify the position of I. I think once if you add the element, automatically, sir, one more location will be created. So we are not using array here, we are using array list. Sir, where that object will be inserted, that one will be located at this 5, sir. Now, sir, I is nothing but the node which we inserted. Its position. Okay. Sir, what is the position of I here? Sir, my I position is nothing but, sir, 5, sir. My I position is nothing but 5. We have to find out. Okay, we have to find out, sir, left parent to this, and I mean right left child to this and right child to this. We have some formulas are there. Suppose if you have I as a node, sir, its left node will become 2 into I plus 1, and its right node will become 2 into I plus 2. Have you observed? If you take I is equal to 0, 2 into 0 plus 1. In first location, left child is there. So 2 into 0 plus 2. In second location, right child is there. If you take I is equal to 3, 2 into I, sir, 2 plus 1, 3. At third location, left child is there. So 2 into I, 2 plus 2. Sir, 4. In fourth location, we have right child. Like that, this small formula is there. The total story is based on this formula. Okay, the total story is based on this formula only. Now you have to identify this one, sir. So what is the left child? 5 into 2, 10. 10 plus 1, sir, 11. So here 10 plus 2, 12. Sir, is these positions are there here? No, these positions are not there. Then what we have to do? Sir, you have to go for its parent. You have to go for its parent. Sir, what is the parent I value? Sir, parent I value is nothing but 2. Try to find out its left child. Sir, what is its left child? 2 into 2, 4. 4 plus 1 is nothing but 5. Okay. Try to find out right child. Sir, what is the right child here? Sir, we are getting 2 into I. 2 into 2, 4. 4 plus 2 is nothing but we are getting 6. But this one is out of bound. So this one is also out of bound. This one is also out of bound. Now we have this value. Now compare these two, sir. Okay. So we have to compare these two and swap these two values. Here we are going to get 1 and here we are going to get 4. So in second location, we are going to get 1, sir, and in fifth location, we are going to get 4. Like this we have. Sir, next again for I. So who is the immediate parent? Your I will become 0. Okay, your I will become 0. Now we have to compare. Sir, its left child will become 1 and its right child will become 2. Okay. Now compare with left. Sir, is this is a higher value? Yes. Compare here. Is it is a higher value? No, right? Then what we have to do? We have to perform swapping. Here 1 will come and here we are going to get 2. Okay. Sir, here we are going to get 1 and here we are going to get 2. Okay. Sir, what is the tree that we got here? 1 and 3 and here we got 2 and here we got 5 and here we got 10 and here we got 5. Is it a 5? No, it is 4. Correct. Sir, is it greater? Yes. Is it greater? Sorry, is it lesser? Yes. Is it lesser? Yes. Is it lesser? Yes. So less than this, less than this. So my element is ready to delete. Okay. So if you want to access, we have to call which method? Peek method. If you want to, after accessing, compulsory you have to perform remove operation. Then only the next smallest element will come here based on these kind of steps. Okay. Definitely after removing one element, that tree is not in a proper heap format. We have to apply some algorithms called heapifying structure. Then only you are going to get that particular value, sir. Okay. I think you people got clarity, sir, how you can able to work with this. So insertion of an element into heap. Can you please confirm, is the concept is clear? Clear, please confirm everyone, because I am not seeing response from everyone, sir, here. Right. Right. Sir, to demonstrate this, I will go for a program. Then you people can understand well how it is going to be implemented. Directly, I will go with the program, sir. Have a look once. Here already priority queue is there. I don't want this. I will implement my own priority queue. I will implement my own priority queue. Sir, how it is implemented? I am going to take one special class within this test class only. What is that class? Is nothing but a static class. So heap static class, I am taking the class name as a heap, and I am going to take an array list. So which is going to take an integer value, and the array name is nothing but arr is equal to new array list. Like this I am creating. Okay, so I will implement public void which method add. So I am going to pass some integer, it has to add. Sir, how you can able to add? Immediately you have to add. Where it will be added, that data at last, right? At last it is going to be added. Okay, in the diagram you can see, whenever we are adding the data, it will be added at last position always. Sir, after this what we have to do? Sir, you have to find out, sir, child index and then parent index. Sir, what is the child index? So child index is nothing but in this array, whatever index is there at the last, that means size minus 1. What is the array list size here? We have 6 elements are there. 6 minus 1 means what? 5. Sir, 5 is the index location of that child. Sir, now you have to find out parent index. Sir, very simple. How to find parent index? So child index minus 1. Okay. So child index minus 1 by 2. Very simple. So here you can able to see, if my child index is if my child index is 5, sir, 5 minus 1 by 2, that is 4 by 2 will come parent index. So here consider child index is 3. 3 minus 1 by 2, 2 by 2, that is nothing but 1 parent index. Sir, 4 minus 1 by 2, 3 by 2, which we are going to get 1 parent index. Like this, we are getting child index and then parent index. Now what we have to do? You need to compare. Sir, in that array, try to get the element which is located at child index. It should be always less than. Okay, right? So if this value should be always less than. If it is less than, so ARR dot, so get of parent index. If it is less than parent index, what we have to do? We have to do the changes. Sir, what changes? So here you can able to see previously at the very beginning. So here we have what is the actual tree? We have 2 here. Yeah, we have 2 here, and then 3 is there here. Next here we have 4. Next we have 5 is there, and 10 is there. Recently added element is 1. Sir, now check, is 1 is less than 4? Yes, that means this is not the correct position. We have to interchange these two values. For that I am writing, sir, something like, is it a swapping? Yes, but it is array list. If it is array, directly we can swap by changing these index values. But since it is an array list, we have to write some different technique. First, to hold the value which is there at a child location. Get of child index. In the child index, whatever value is there, that I am going to capture in array. I mean in temporary variable. Sir, in array list, we have a special method is there called set, where you have to give index value and then data. Sir, now what I am going to do in this set value? Sir, child index is there, right? In this position, can you please take ARR dot get parent index, so that what will happen? Sir, in this position, parent index is what? So 0, 1, 2, so 3, 4, 5. Parent index is 2. So here I am going to get the value which is there in the parent index, which is nothing but 4. That 4 I am going to put it in child index. That means here we will get 4. Next, sir, we have to replace this 1 here, right? But 1 is there in the temp. So now what we have to do? Again, ARR dot set of, I am going to set this value in parent index. Which value we have to take set? That temporary value. That's all. Swapping got completed. So these two values got interchanged. Now this process you have to repeat for these two, right? Because here only imbalancing occurred. We have to repeat this for these two. So now what we are doing here? So now your child index will become parent index. But how to calculate parent index recursively? Sir, already we know the formula, right? Child index minus 1. Now in this example, sir, child index is nothing but parent index I am assigning. What is the parent index here? 2. Now calculate parent index. How to get parent index? Child index minus 1. So 2 minus 1, 1. 1 by 2 means what? 0. Now this process will be applied for these two. Same thing, while loop. If it is less than, it will repeat it. Otherwise, no need to repeat it. This is nothing but a simple method to insert the data into the heap, sir. To insert the data into the heap. Then we have one more method is there called public integer peak. Peak method, we are not required to write anything. Simply you can able to return ARR dot get of 0. So the element which is located at 0th location, the element which is located at 0th location, simply it will return. Sir, nothing is there, sir. Peak means what? Topmost element, right? That's why I am returning the element which is located at 0th location. Can you please confirm, is the skeleton of add method and peak method, is these two are clear for you people? Clear? Right, sir. Right. So with this, I'm going to stop today's session. Sir, tomorrow we will see how you can able to remove a node from heap, sir. How you can able to remove a node from heap, and heap sort is there. These two we will discuss in the tomorrow's session. Okay. Right, sir. Thank you. I will upload the running notes within a few minutes. You can download. Thank you, guys. Tomorrow class is there as usual at 7 o'clock. Okay. Right. Thank you.